So the unit circle. Unit circle is basically a circle that's centered at the origin and has a radius of 1 everywhere around that circle. So that length there, the radius of that circle, and that length would be 1. So this ordered pair would be the ordered pair 1, 0. So that's 1 unit long. That would be the length of 1. So when we have a radius here, it's still a radius, so all the radii are 1. So when we look at that, if I made a triangle right here, so that's a little right triangle right there. This length is no longer 1, it's a little shorter. It's a little bit shorter than 1. And if I knew that that angle was 45 degrees, well, I know this angle is also 45 degrees. They're both equal to each other. And I know that this length is now 1. So this piece, how I could find it is, I know the sides of 45, 45, and 80 are basically, if you remember from math 2, the sides of a 45, 45, and 80 right triangle. You guys probably would have said something along the lines of, each side is x, and their hypotenuse would be x squared root of 2. So if I want to find out what x was, basically I could divide all sides by the square root of 2, and that's be what x is. That's why I can figure out what x is. So if I know that this side is 1, I know that I could divide each one of these sides by 1 over the square root of 2. 1 divided by the square root of 2. They'll give me the length of each one of those sides. So typically, if you have the number 1 divided by the square root of 2, you really don't leave it that way. You typically rationalize that. So in order to rationalize that, you multiply that by the square root of 2 over the square root of 2, giving you square root of 2 over 2. So that I know that each of these sides are 1 over square root of 2 or square root of 2 over 2. So when I look at this point right here, this point has an x value that's right here, has a y value that is height, so that's his y value. So that ordered pair would be the x value and the y value. And the x length there is 1 over square root of 2, or square root of 2 over 2. And the y value is also the exact same thing, that's how high it went. So this ordered pair has square root of 2 over 2, comma, square root of 2 over 2. So that's the ordered pair for this point right here. And if I want to find sine, cosine, and tangent, basically in a unit circle, sine is the y value. Sine of theta is always a y value. And cosine of theta is always the x value. Keep it straight, just know sine always goes y. So yes, cosine is the x. Sine is always a y value in those ordered pairs. So this is an example of a unit circle where each of these angles correspond in degrees and radians. So this is 30 degrees, and 30 degrees same thing as pi over 6 radians. 45 degrees same thing as pi over 4 radians. 60 degrees same thing as pi over 3 radians, and 90 degrees same thing as pi over 2 radians. And remember earlier what we said was x and y are those coordinates, and x represents sine, x represents cosine, and y represents sine. So if I want to find, for example, cosine of 60, I know cosine of 60 has equal to this, because cosine at 60 is 1/2. Or you look at cosine of pi over 3. Since pi over 3 is the exact same thing as 60, except 1 is in radians and 1 is in degrees. Cosine of pi over 3 is also 1/2, because again, they're the same thing, just different units of measurement. If you look at the sine value, sine at 60 is going to be this, square root of 3 over 2. And that's how I find it. That's how you find sine and cosine using the unit circle. And one thing you can't find right away is secant, cosecant, tangent, and cotangent. So remember that if you knew sine of an angle was a opposite of hypotenuse, cosecant of that angle is the reciprocal side. So cosecant of that angle will be hypotenuse over opposite. So technically, if you want to figure out what any of those were, if I knew that sine of 60 was equal to the square root of 3 over 2, well, I just know that cosecant of 60 would be the reciprocal of that. So cosecant of 60 degrees would be 2 divided by the square root of 3, which we rationalize. 2 divided by the square root of 3, we multiply by the square root of 3 over the square root of 3. You get 2 square root of 3 over 3. So we just know that, but it could be this or that, they are the same thing. Typically, we rationalize it and we call it that. So anyway, if you want to find sine, if you know sine, you want to find cosecant, you just basically flip it. If you know cosine, if you want to find secant of that same angle, you just take that angle and you flip it. So cosecant will be 2 over 1. So I know cosecant of that reduces to 2. What you're going to find is the cosecants and secants, so the cosecants over here and the secants over there, typically always going to be greater than 1. And sine and cosine are always going to be numbers that are smaller than 1. So they're always going to be decimals that are in between 1 and 0, whereas the secant and cosecant would be always going to be greater than 1. So secant, cosecant will always be greater than 1. And then sine, cosine will always be in between 1, well, less than 1. And the reason why that makes sense is since the hypotenuse is always larger than the opposite side, you always have a larger number divided by a smaller number. For example, 7 over 3. A larger number divided by a smaller number is an improper fraction. And that really is a mixed number that's going to be greater than 1. So it is a nice little thing to know, and it's one of those things that if you had to narrow down answers for whatever reason, that's a good thing to help you narrow down answers if you're taking some kind of multiple choice test. You know that cosecant has to be the one that's larger than 1, and you know sine and cosine have to be smaller than 1. So all those are ways you can find sine, cosine, secant, and cosecant. Next thing I talk about is finding tan and cotan on the unit circle. So we have lots of things that we know that tan is equal to. For example, we know tan is equal to opposite over adjacent. That doesn't help us much here because we don't have a triangle. We also know that tan is equal to 1 over cotan. That'd be one of the reciprocal identities. That doesn't help us much because you don't have cotan either. So another thing that tan is actually equal to is, tan is actually equal to sine of that angle divided by cosine of that angle. So you want to find what tan is, you can basically take sine divided by cosine, you have what tan is. So if I want to find, say, tan of, I'm going to use one of the negative ones. Well, I'm going to use one on this side, tan of 150. So I want to find tan of 150 degrees. Basically what you're going to have is sine. So cosine would be, cosine of 150 would be here. And sine of 150 would be right there. So the second piece, this piece is sine of 150, the y value. That's the x value. So if you want to find out what, if you want to find tan of 150, you find sine of 150 divided by cosine of 150. So since we now know that sine has to be the fraction 1/2, and we know the cosine has to be the fraction negative square root of 3 over 2. What we have is 1/2 divided by negative square root of 3 over 2. And we can simplify that. So this fraction reduces to be, well, the same thing as that 1/2 divided by the bottom fraction. So what you already know is that's a complex fraction. So we take the first one, 1/2, we multiply by the reciprocal of that. When you multiply that, you wind up having 2 divided by negative 2 square root of 3, which of course reduces to be, these count out to be 1s. So that reduces to be 1 divided divided by negative square root of 3, which is what it is. We rationalize that, and you can figure out how to rationalize that if you want to review it. But basically, when you rationalize that, you multiply top and bottom by the square root of 3, and you should wind up being left with negative square root of 3 over 3. Put a negative sign on top, but it didn't really matter. You put a negative sign on top or the bottom. It's just going to be negative square root of 3. So you can call it this, you can call it that, both equivalent. Depends on how far you want to simplify. And I'd like to point out to my students that if you notice that this is divided by 2, and that's also divided by 2, you can really save some work. Since both of those divided by 2, I can really set the numerators equal to each other, over each other. So it's really going to be 1 divided by negative square root of 3, which is what we found earlier, just a little faster. So if you notice that both of those are divided by 2, you can just take the numerators and divide them. And then that's what it will be until you rationalize it, and you get negative square root of 3 over 3. But it's just a shortcut if you notice that, if you ever notice that. And that's pretty much it. That's pretty much the entire video for unit circles.